have our exit plaque or our entry plaque, depending on which way you're going here, that now tries to put a few other things into context. So remember, we said on this scale, and these are the Voyager portrait of the planets. This is the pale blue dot photo right there that Carl Sagan has that brilliant speech that he gave about, which if you haven't read it or heard it recently, just Google pale blue dot Sagan and you'll get the video of him doing the speech. It's just incredible to listen to him. But that was when Voyager was almost 4 billion miles away, and looking back to get 1 pixel for the Earth there. But then you remember, on this scale where we've walked in a few minutes all the way out to Pluto, you'd have to continue 4,000 kilometers to get to the next grapefruit, the next star. When you think about it that way, it's kind of almost remarkable that we can see stars at all, but they're really, really bright. But that's why they're dots in the night sky. With even the best telescope can barely get any resolution, and not on ordinary stars like our sun. They're still just a dot to even the most powerful telescopes. But that's just to the nearest star. If you want to keep going beyond that, you cannot use this scale anymore, because you'll start wrapping around the Earth pretty quick, and you run out of space on the Earth to do it at this scale. If you want to continue, you're going to have to change the scale. So there's a lot of different ways to do that. If you take the scale from 1 to 10 to the 10th, or 1 to 10 billion, and go another factor of a billion, so make it 1 to 10 to the 19th, now the galaxy will fit on a football field. But now the distance from the sun to Alpha Centauri is a few millimeters, and the planets have become, and the sun has become microscopic, right? My personal favorite way to put this into context is just to try to mentally imagine stars are separated like grapefruits, thousands of kilometers apart, and then combine that fact with the number of stars that there are in the Milky Way galaxy. And to rough numbers, we'll call it 100 billion stars in the Milky Way galaxy. There's actually probably several hundred billion. The mass interior to the Earth, to our orbit, is close to 100 billion, and then there's more out. But our sun is more massive than most stars. Most are smaller, so probably several hundred billion. We're just called 100 billion. So your assignment is tonight, if you have any trouble falling asleep, if you're like my wife with her insomnia, and you think you're going to count sheep, don't do that. Count stars. So 1, 2, 3, and don't stop until you get to 100 billion, or if you can, stay awake that long. And this is really fun to do with kids. I love, I remember I got a lot of these ideas from my work with elementary school kids to begin with. And so if you tell kids this and ask them how long is it going to take you to get to 100 billion, like, hour or whatever, and the first thing they'll tell you is that you're counting 1, 2, 3, because I said we'll do it at 1 per second, and they're like, come on, I can count so much faster than that, right? And they'll show me, right? What are your prices? It's great, okay, but what about when you get to 78,942,365,172? Will you still be able to say it in 1 second? And you know what comes next. So, it's going to get challenging, but if you could, it's very easy. 100 billion seconds it would take you to count. And so you can just confirm on your calculators later that 100 billion seconds is about 3,200 years. Okay, you got that? So just to count all the stars, it would take you more than 3,000 years. Just to count them, not give them names, look for planets, study them. 3,000 years, and every pair of them, roughly speaking, separated like grapefruits across the United States. If you can fathom those two thoughts at the same time, then you've begun to get a sense of our place in the galaxy. And that's just our galaxy. Then you go out to the universe, and a picture like that, you've all seen the James Webb Space Telescope image of all of those galaxies, 100 billion and more galaxies also throughout the universe. And you really start to get the idea that, as we said in the beginning, we are not the center of the universe. And yet, in that entire universe, to our current knowledge, the only way the universe knows it exists is right here in our heads. The universe is self-aware of its own existence because of us. It's possible there's others out there who have also made the universe self-aware, but we don't know of them yet. So you take that thought and you say, okay, so we destroy our civilization, wipe out our species. What's the big deal? Well, of course, none of us would really be happy about that anyway, right? You want your species to survive. It's kind of an evolutionary thing. But from the universe's point of view, you've destroyed the self-awareness of the universe that the universe spent 14 billion years working to achieve. So my opinion is we shouldn't destroy ourselves, because it would be a really terrible thing to do to the universe. Because it's self-awareness. And again, you combine that with we're not the center of the universe, you think maybe we should all treat each other a little bit better. So I think I'll stop there. Any more questions before we go inside? Yeah.
I think what blows my mind is the sun is the size of a grapefruit a half a mile away. You can't even see the sun.
You can't even see it here.
It's just amazing that we can even see objects like Pluto that far away from light reflected from the sun.
And it's just light reflected in the case of the planets. Of course, Pluto you can't see with the naked eye, but with the telescope you can. But yeah, it's pretty mind-boggling just to fathom that part of it, right? Just to hate to dump too much on astrology, but since I did already, and in astrology, it's important what constellation the planets are in. Well, where are the constellations on this scale? I mean, they're not even going to fit on Earth for most of the stars, and they're going to tell you that because if you're looking from a certain place, you see this little dot thousands of miles in front of some other dots out there, that matters. It starts to become a little bit crazy to fathom that there's actually anything there, which of course there's not. Yeah.
The telescopes that were used, I think you quoted in the 1700s, to identify Uranus. Is there much written about how they were made, how they were constructed, the optics? I mean, I'm visualizing contractors like Perkin-Elmer and the mirrors and so on. They didn't have them.
No, I think the Herschels, I think, made their own mirrors. You can look up pretty easily the details, but yeah, it was kind of amazing, but it was a lot of hard hand work to do these things. And especially if you go back to even like Galileo, you got to realize his optics were pretty poor quality. Any cheap pair of binoculars is way better than what he used to make those famous discoveries.